So far we have seen the equations of the straight line in different forms and now we will turn our focus to find out the angle between two given lines. Let's say we are given two straight line equations. Y is equal to m1x plus c1 and y is equal to m2x plus c2, and we are trying to find out the angle between these two lines. So let's say the first line is like this and it makes an angle, we call it theta 1, and we know that theta 1 is related to m1 by m1 is equal to tan theta 1. And this one is the second line L2, and this is making an angle theta 2 where tan theta 2 is given by its gradient m2, and we are required to find out this angle. Let's call it phi. This angle phi, we know that this angle is theta 1, so this angle is going to be 180 minus theta 1, and sum of these three angles is 180. So theta 2 plus 180 minus theta 1 plus phi is equal to 180 degree, and from here we can find the value of this angle between these two lines in terms of theta 1 and theta 2. So phi is equal to 180 cancel, phi will be equal to theta 1 minus theta 2. We know the values of, we don't know the values of theta 1 and theta 2, but we know the values of tan theta 1 and tan theta 2. So tan theta 1 is nothing but m1 and tan theta 2 is equal to m2, and therefore we can take tangent on both sides of this equation. So tan phi is equal to tan theta 1 minus theta 2, and at this point we can use the trigonometrical identity. Tan theta 1 minus tan theta 2 is equal to tan theta 1 minus tan theta 2 divided by 1 plus tan theta 1 tan theta 2. And we know, we don't know the, we can express tan theta 1 as m1 and tan theta 2 as m2. So we will get tan phi is equal to m1 minus m2 divided by 1 plus m1 m2. This is the formula you will need to memorize to find the angle between these two lines. As an example, let's say we are given two straight lines x minus y root 3 is equal to 5. You should note that the angle between these two lines do not depend upon the c1 and c2, these constant. Which means, what does that mean? If I draw a line parallel to this which making the same theta 2 angle, then the intercept changes from c2 to c2 dash, but it's still making theta 2 angle, and this angle phi still remains the same. So the angle between two lines depends only upon the gradient of these two lines, the angle that it makes with the x-axis, and not upon the intercept. So let's say we have an equation, the two lines are given by x minus y root 3 is equal to 5 and x square root of 3 into y into x plus y is equal to 7, and we are required to find the angle between these two lines. So from here we can express this at y is equal to x upon root 3 minus 5, and this we can write y is equal to minus 1 upon root 3 into x plus 7. So we have m1 is given and m2 is given. And then now we can find out tangent of phi. So m1 is 1 upon square root of 3 and m2 is equal to minus 1 upon, this is minus square root of 3. m2 is minus square root of 3. So tangent of phi is will be given by m1 minus m2 minus root 3 is plus root 3 divided by 1 plus 1 upon square root of 3 into minus square root of 3. Square root of square root 3 cancels, 1 minus 1, this is 1 upon 0. And this is possible only when this angle phi is 90 degree. In general, you can have a non-infinite value which will correspond to tangent of some angles. The next thing we will do is find the condition that the two lines are parallel. When two lines are parallel, let's say these two lines are like this, they will be parallel. In that case, the angle between these two lines will be 0. They will meet at infinity. So the angle between these two lines will be 0, and for that the condition is tan phi is equal to 0. And that means m1 minus m2 is equal to 0, or m1 is equal to m2. So the two lines y is equal to m1x and plus c1 and y equal to m2x plus c2, they are parallel, or the angle between them is 0 when their gradients are same. And another special case is when two lines are perpendicular, and this one is going to be very important. Two lines are perpendicular when tan phi is equal to 1 upon infinity. When phi is equal to 90 degree, and this will imply that tangent phi is equal to infinity, which means 1 upon 0. And this is possible only when this denominator is going to be 0, or 1 plus m1 m2 is equal to 0, or m1 m2 is equal to minus 1. This is the condition you will be using very often, so you will need to memorize this one for the condition of the two lines to be perpendicular. Now let's do some problems on these two results. Angle between two lines, the condition for parallel, and the condition for these two lines to be perpendicular. So find the equation of the straight line passing through point 2,3. We need to find the equation of a straight line passing through the point 2,3 and perpendicular to the straight line 4x minus 3y is equal to 10. So any line passing through point 2 and 3, we have seen in the earlier video, will be given by y minus 3 is equal to m into x minus 2. You can verify this by substituting these values here and see that the left and right hand side both satisfy. If you put y is equal to 3, it's 3 minus 3, 0. If you put x equal to 2 and 2 minus 2, that is also 0. So this is the equation of a straight line that passes through the point 2 and 3. Now the gradient of this line is, if you simplify, you can write it always in the form of y is equal to mx plus c, where c will be minus 2m plus 3. And the gradient of this line is m, and the gradient of this line will be given by, let us call it m1, and that will be equal to, if you take 4x this side, and then it will become y is equal to 4x divided by 3. We are not worried about the c. So the gradient of this line will be 4 by 3. And And if you call it this gradient m2, so the condition for this line to be perpendicular to this is m into m1 is equal to minus 1. This implies m into 4 by 3 is equal to minus 1, or m is equal to minus 3 by 4. This we can substitute the value here and we get y minus 3 is equal to minus 3 by 4 into x minus 2, and we can simplify further to find the equation of the line perpendicular to this line and passing through the point 2, 3. But there are several other simplified way to do this problem, and that's what we are going to explore. We saw that if we are given a line y is equal to m1x plus c is a line, then we know that any line perpendicular to this will be of the form y is equal to minus 1 upon m1x plus some constant k. But if we are given a, because in this case the product of these two terms will be m1 into minus 1 upon m1 minus 1. But if we are given a line in the form of ax plus by is equal to c, then we can show that a line perpendicular to this will be of the form bx minus ay is equal to some other constant c dash. We can see that because if we take the gradient of this line is minus a by x b, and gradient of this line is b by a, and if I multiply these two, then we get a by b multiplied by b by a. This multiplication is minus 1, and therefore these two lines are perpendicular to each other, and therefore we can also write this directly that any line perpendicular to this line can be written as 3x plus 4y is equal to a constant, let's say lambda. So the trick is just interchange these two things and inverse the sign of one of them, either x or y. Here we have interchanged the value of sign of y, and that becomes plus. And now this line passes through the point 2, 3. Therefore the second condition will give us 2 into 3 is 6 plus 4 into 3 is 12 is equal to lambda, or lambda is equal to 18. That means the equation of that line will be 3x plus 4y is equal to 18. So in many cases one or the other method will be helpful. Let's do another problem. Find the equation of a straight line passing through the point 2 and minus 3. The line passes through the 2 and minus 3 and perpendicular to the straight line joining 5, 7, perpendicular to line joining 5, 7 and minus 6, 3. So one way is to find the complete equation of the straight line passing through these 2 points. But we don't need to do, all we care about is find the gradient of the line perpendicular to this line. So first we will find the gradient of this line. And gradient of this line, let us call it m1, will be equal to y2 minus y1 divided by x2 minus x1. So I can do y1 minus 7 minus 3 is 4, and 5 minus 6 is 5 minus 6 is 11. So this is the gradient of this line. And the gradient of the line perpendicular to this, let's call it m2, will be equal to minus 1 upon m1, or minus 11 by 4. And therefore the equation of the straight line passing through this point and with this gradient will be given by y minus y1 is equal to m into x minus x1. And y1 is minus 3, so y plus 3 is equal to minus 11 by 4 into x minus 2. You can simplify it a little bit. 11x plus 4y is equal to, this is 11 into 2, 22 minus 12 or 10. This is the another variation of the problem. All you need to do is find the gradient of the line perpendicular to the line joining these 2 points. So the perpendicular condition is used very often in all the problems. Find the equation of the straight line which bisects the and is perpendicular to the straight line joining points AB and A dash B. So you are given 2 points AB and A dash B dash. Join these 2 lines, find the equation of this line, and this line is such that it is perpendicular to this line and is joining the middle point of this. So the middle point of this is A plus A dash by 2 and B plus B dash by 2. And we can first need to find out what is the gradient of this line. So for that, let us first find the gradient of this line. The gradient of this line, let us call it M1, is equal to Y2 minus Y1, B dash minus B divided by A dash minus A. So the gradient of the line perpendicular to this will be equal to minus 1 upon A1 minus A dash minus A divided by B dash minus B. And therefore, the equation of this straight line will be equal to Y minus Y1 is equal to M into X minus X1. Where X1, Y1 is the point through which this straight line passes, and in this case, it is this point. And the gradient of this line is this quantity. So we can write Y minus A plus A dash by 2 is equal to M is minus A dash minus A divided by B dash minus B multiplied by X minus Y minus B plus B dash. This quantity here, X minus A plus A dash divided by. You can further simplify it and get the cleaner answer. So this is pretty much about the angle between 2 lines, the condition of the perpendicular thing, and you can keep doing more problem. Let's take a break and cover the equation of a straight line making some angle with a given straight line. Let's now focus on trying to find out the equation of a straight line making a certain angle with a given line. And let the given line is given by y is equal to mx plus c. This is the line, that is y is equal to mx plus c. And because m is given, we can always find this angle, and let's call this angle theta. Now we are required to find out the equation of a line passing through a given point, let's say this here, and that line is required to make some angle with this given line. Let's call this angle alpha. And if I am required to find the equation of a line that makes certain angle alpha, then in general there are two such lines. For example, this line is also making an angle alpha, and this line is also making an angle alpha with respect to these two lines. So in general, from a given point P, x1, y1, there are two lines that makes an angle alpha with respect to that given line. We are required to find out the equation of this line and the equation of this line. This is x-axis, y-axis. One condition is already given, that this line is passing through px1, y1. The only other thing we need to find out is, if we could find the gradient of this line, then our problem will be solved. Or if we can find out the tan alpha of this angle, then our problem will be solved. But we are given m here. So to do this, this angle is alpha. That means this angle is also alpha. And from this triangle, this angle is going to be this angle. Let us say this angle is phi, which is the gradient of this line, which will give the gradient of this line with respect to the x-axis. So this is phi. This is going to be 180 minus phi. And from this triangle we can write theta plus alpha plus 180 minus phi is equal to 0, is equal to 180, or phi 180 cancel, phi is equal to theta plus alpha. So in theory we are now able to find out this angle, and this will help us finding the gradient of this line. In the same way, in this angle is alpha, and this angle is 180 minus alpha. This angle, let's call it phi dash. Then theta plus 180 minus alpha plus phi dash is equal to 180. 180 cancel, or phi dash is equal to alpha minus theta. We have these two equations, and from where we can take the tangent of this angle. Tan phi is equal to tan theta plus alpha, or tan phi is equal to tan theta plus tan alpha divided by 1 minus tan theta into tan alpha. And tan theta is the gradient of this line m. So we can write it m plus tan alpha divided by 1 minus tan alpha. And tan phi is nothing but the gradient of this line. Let's call it, we'll leave it here. In the same way, we can take the tangent of this angle. Tan phi dash is equal to tan alpha minus theta, which is tan alpha minus tan theta divided by 1 plus tan alpha tan theta, and this will be equal to tan theta is equal to m. So we have tan alpha minus m divided by 1 plus m. We have m here, 1 plus m tan alpha. We can simplify this. So the two gradients, this one has a gradient tan alpha plus m divided by 1 minus m tan alpha, and this one will have a gradient tan alpha minus m divided by 1 plus m tan alpha. We know the gradient of these two lines. We know that it's passing from x1, y1. So we can write down the equations of these two lines. The equation of this line will be y minus y1 is equal to tan alpha plus m divided by 1 minus m tan alpha multiplied by x minus x1, x dash. And the equation of this line is also passing through x1, y1 and has this gradient. So this equation will be y minus y1 is equal to tan alpha minus m divided by 1 plus m tan alpha divided by x minus x dash. So this is how you can find out the equation of a line which is making a certain angle which is not perpendicular or parallel to a given line. If it's perpendicular or parallel, you can use the easier method of using the equation m1 m2 equal to minus 1 or m1 is equal to m2. So let's do this question from this book S.L. Loney. I'll keep this. I'm trying to make sure that our results are good. This one is okay. It looks like there is something wrong in this one. This is alpha, this is 180 minus alpha. Okay. So we took this phi dash angle from the negative x-axis. But in reality, we should have taken this angle. This angle is what is required. If this is phi dash, then this is going to be 180 minus phi dash. Which means that in our equation, we should have taken theta plus this equation. Theta plus 180 minus alpha, plus instead of phi dash, we should have 180 minus phi dash. 180 cancels, phi goes this side, so phi dash, call it phi dash, will be equal to theta 180 plus theta minus alpha. And this will actually be tangent of 180 plus theta minus alpha. And tan 180 plus theta is tan alpha. So this will be equal to tan theta minus alpha. So the signs will get reversed. It will become tan theta minus tan alpha. Rest of the things should be the same. So this will actually be m minus tan alpha. The result is m minus tan alpha divided by 1 plus m alpha, and then m plus tan alpha. So this was the mistake in the last one. We need to see the angle of this line from the positive x-axis. Like in this one, this angle is from the positive x-axis. So this result was good, but this result was not good because we had taken the angle earlier from the negative x-axis. So you need to make sure that this like. Let's do one question. We need to show that the equations to the straight line passing through the point 3, 2. We are given the point 3, 2 and inclined 60 degrees to the line square root 3x plus y is equal to 1. 60 degree inclined to this line. So we will not go through this process again, but substitute the values in this equation. So the first line will be given by y minus y1, y minus 2 is equal to m. M is the gradient of this line, this given line, which is, let us write the m, is equal to y is equal to mx minus square root of 3. And alpha is given as 60 degree, or we can write tan alpha is equal to square root of 3. So m is given, alpha is given, we can find out tan alpha, and y1 and x1 are given. So we can write down the equation from here directly. Y minus 2 is equal to m is minus root 3 plus tan alpha or tan 60 degrees plus square root of 3 divided by because minus 3 plus 3 is 0, we don't need to write everything on the bottom. We can write 1 minus m tan alpha. So this thing is 0, the whole right hand side becomes 0, y minus 2 is equal to 0. This is the first equation. For the second equation, we have y minus 2 is equal to m minus tan alpha minus root 3 minus the square root of 3 divided by 1 plus m is minus square root 3, tan alpha is square root of 3 multiplied by x minus 3. Or y minus 2 is equal to minus 2 root 3 divided by 1 minus square root of 3 is minus 2 x minus 3. Minus 2 cancels. Y minus 2 is equal to square root of 3x minus 3 root 3. You can simplify it a little bit to y minus root 3x minus y minus 3 root 3 plus 2 equal to 0. So this is, you can, in case you don't need to memorize it because it's not used very often, but you need to follow this step of assuming the angle. Make sure you do this in the right direction from the x-axis and then derive it right on the spot. So this should cover from the Untitled chapter number 6, and we will do one more topic and then we'll stop it here. We are trying to find out the condition that find the condition that a point x dash y dash is on one or other side of the line ax plus by plus c is equal to 2. We are given a line, a straight line, and its equation is ax plus by is plus c is equal to 0. If we are given a point x dash y dash, then three things can happen. The point can be on this side of this line, or it can be on the line. It's very clear that if this point, if we substitute these values x dash y dash on this equation, and then this point satisfies this equation, then that point has to be on this straight line. But if we evaluate this quantity ax dash plus y dash plus c, it can come. How do we know that it is on this side or on the other side? That is what we are trying to investigate. Let us say this point lies somewhere here. We call it x dash y dash, and we draw a perpendicular on the x-axis. Then this length is going to be x dash, and this length is going to be y dash. And let us say this line cuts this line somewhere here. When this line cuts this line at x is equal to x dash, then we can find the coordinates of this point. And let us call it Q. Then if it has a coordinate, the x coordinate we know is x dash. Now the y coordinate, let's say, is y double dash. Then x and y double dash satisfies this equation. That means ax dash plus by double dash plus c will be equal to 0. And from here we can get y double dash is equal to minus ax dash plus c divided by b. What does that mean? We need that we have found this length. This length is minus ax dash plus C divided by B. Now we know this length and we know this length. So two things can happen. If this point y dash is on this side of this line, then this length will be bigger, which is y dash, and this length will be smaller, call it y double dash, must be greater than or equal to 0. But if this point is somewhere on this side of this line, then this length y dash this length y double dash will be greater than this length y dash. So again, if this point P is on this side of the line, then this length will be greater than this length y double dash. That is what is the first condition. And if it is here, then this length y dash must be less than this length of y double dash, or y double dash minus y dash must be greater than 0. And from these two things, we can substitute the value of y double dash. We get y dash minus y double dash is nothing but ax dash plus c divided by b must be greater than 0. Either this will be true or this will be true, depending upon whether this point is on one side of the line or the other side of the line. So either this or y double dash is minus ax dash plus c dash divided by b minus y dash is greater than 0. We can simplify it, so we can write ax dash plus by dash plus c divided by b, ax dash plus by dash plus c divided by b is greater than 0, or minus ax dash. You can in the same way simplify this one, you minus ax dash plus by dash plus c divided by b greater than 0. So if this thing happens, then the point will be on the one side, and if this thing happens, the point will be on the other side. So both b is same for the both of sides. So we can conclude that the point x dash y dash is on the one side of the line or the other side of the line, depending upon the sign of this quantity, ax dash plus by dash plus c. So if you are given 2 points, one is, let's say, PQ and other is RF, and you are asked, can you find out if these 2 points are on the same side of the line or the other side of the line? All you need to do is substitute this PQ in this quantity, and then substitute RS in this equation and evaluate this thing. If both of them comes positive, then both the points are on the same side of the line. If one has a positive sign, other has a negative sign, then they are on the different side of this line. This is how we can find out if a given point, 2 given points are on the same side of the line or the other side of the line. There is another way to solve the same thing, and that is by finding the ratio in which 2 given points bisect the line. Let's say again the same way, this is the equation of the line ax plus by plus c is equal to 0, and we are given 2 points, x dash y dash and x double dash y double dash. They can be on the same side or they can be on the opposite side. We don't know beforehand if they are, we are just assuming that they are on the 2 opposite sides, and then trying to find out if our assumption is true or not. And let us say the line joining these 2 lines divides this line in the ratio m1 and m2. Then we can find out the coordinates of this point. The coordinates for this point will be m1 could write anything, but let us say make it this one x dash y dash, and this x double dash y. It does not change the anything, but it makes us remember to think. We have been remembering mx2 plus nx1, so it fits with that formula, but it does not change the result. m1 x double dash, or we should just write x1 y1 and x2 y2. So the coordinate of this point will be mx2 m1 x2 plus m2 x1 divided by m1 plus m2, and m1 y2 plus m1 m2 y1 divided by m1 plus m2. Now this point, this coordinate of this point satisfies this given equation of the straight line, so we can substitute this and write this equation. We can write a into m1 x2 plus m2 x1 divided by m1 plus m2 plus b times of m1 y2 plus m2 y1 divided by m1 plus m2, and then plus c is equal to 0. Let's multiply the whole equation by m1 plus m2. A times of m1 x2 plus m2 x1 plus b times of m1 y2 plus m2 y1 plus c times of m1 plus m2 is equal to 0. The next thing we do is divide this whole equation by m2. So we get a m1 upon m2 multiplied by x2 plus x1 plus b m1 upon m2 into y2 plus y1 plus c m1 upon m2 plus 1 is equal to 0, and separate the terms that contains m1 and divided by m2 and the terms that do not contain them. So we have m1 divided by m2. This term is ax2 plus by2 plus c plus ax1 plus by1 plus c is equal to 0, and from here we get m1 upon m2 is equal to minus ax1 plus by1 plus c divided by ax2 plus by2 plus c. Now let us analyze these results. What happens if this is also positive and this is also positive? If this is also positive and this is also positive, m1 by m2 is negative. When m1 by m2 is both are negative, that is only possible when both the points are on the same side, because in that case they will be divided externally. Let us consider the easier case, the current case. Let us say one of them comes to be positive and the other comes to be negative. In that case, the positive and the negative becomes multiplied by negative becomes positive, and then m1 and m2 becomes a positive number. So in that case, this point must be in between them. So if they have the opposite side signs, this quantity has one sign and this quantity has another sign. We put substitute x1 y1 and we get one positive value, substitute here we get negative value, then these 2 points are on the opposite sides of this line. And if both of them have the same sign, then what will happen? If then the points will be like this, something like this. This is x1 y1, and then we will get some value of m1 and then some value of m2. So m2 will be this one, but m1 will be negative. It means it is externally divided. We have known that for externally divided point, m1 by m2 ratio will be negative. So that is another way to find if 2 points are on the same side of a given line or on the other side. Finally, as a now we are considering a case where we are given a point P, call it x1, y1, and we are trying to find out, is this point on the same side that contains the origin, or on the other side that does not contain the origin. That means we are given one point which is origin. The x2, y2 for us is now origin. So P2 point is 0, 0. And in that case, when P2 point is the origin, then we evaluate this whole thing, then we get A into 0 plus B into 0 plus C is equal to C. And then our P1 point is x1, y1, and when we evaluate it, we get ax1 plus by1 plus c is equal to c. Now, if this and this both have the same sign, then they are on the same side. So, a given point is on the same side that has the origin if ax x1 plus by1 plus c and c have same sign. If they have the same sign, that means the point lies on the same side as origin. And this is an important conclusion that could be used in the problems. If ax1 plus by1 plus c and c have the opposite side, then that point lies outside the section that contains the origin. So this is pretty much, we have covered a lot of things, and you can keep doing more problems based upon these conclusions, on these understandings, and I hope that it helps you.